Today we're going to be looking at making tables with equivalent ratios and then comparing them on a coordinate plane. Some jokes. How do you want your popcorn, sweet or salty? I want them just like her. We don't have ugly popcorn. We'd like to hire you to steal Thanksgiving. Some vocabulary. This is a coordinate plane here. This is the x-axis, this is the y-axis. Pair of numbers represent a point are called an ordered pair. The spot in the middle is called the origin, and that's what we'll start when we graph. Some review here. What are the coordinates of V? V is 5, starting at the origin, going to 5, 0. What quadrant is S in? -4, -4. What are the coordinates of S? -4, -4, and this is in quadrant 3. 1, 2, 3, 4. This is 1, 2, 3, 4. Quadrants. Quadrants are like chunks of space, okay, represented in these areas. Students in Miss Mac's science class are doing an experiment that requires 250 milliliters of distilled water for every 5 milliliters of ammonia. The table shows the amount of distilled water needed for various amounts of ammonia. So we want to create a table with equivalent ratios. Okay, so I've sort of started to create my table here, and I have 2, 3, 3.5, 4. I need one more. Okay, so I have 250 here because it's 250 milliliters from distilled water to ammonia. Now I encourage you to pause the video and try to fill in the other 4 here in the blanks. Okay, so hopefully you filled in the blanks now. You've taken the time to do that. And you said 200, 175, 150, and 100. There's our table. But our overall goal, though, is to take this information and put it onto a graph. Okay. Before we do that, we have to answer a few questions. Given the table here, what is the unit rate per 1? What's the unit rate? Uni means 1. 50 to 1. Or just 50. Number 2. What is the equation for this table? Well, we know our rate of change is 50. And if we include some number, that'll get our output. Why? Let's see if that works. 50 times 2 is 100. When we put in 2 for n, or x, we end up with 100. So our equation then is y equals 50n. Or you could have also said y equals 50x, or any number. What are all the equivalent ratios for this table? Pause the video and try to answer that question. Two over 100, 3 over 150, 3.5 over 175, 4 over 200, 5 over 250, and there we go. Those are all of our equivalent ratios for this table. Okay, now we want to take our information here from our table, and we want to put that on to a graph. So since we're dealing with the first quadrant here, I'm just going to use positive numbers. Remember, the first quadrant is in this area up here. What do you notice about all the numbers in the first quadrant? They're all positive. Therefore, we're just going to use the top right corner and make it a right angle. If it's not a right angle, it's a wrong angle. So this will be your x values, and this will be your y values. Okay, so I noticed that my numbers go all the way up to 250 and they start at 100. So I don't want to start necessarily at 1. So I'm going to count by 50s here. It's 100, so be 0. It's 150. It's 200. And that's 250. Now, since the numbers are increasing by 1 up here, I can go ahead and just count by ones. Okay. All right, so let's go ahead and graph. Remember that this is our x and this is our y. So we have 2 here on my x, goes up to 100. 3 goes up to 150. 3.5 goes up to 175. 4 goes up to 200. And 5 goes up to 250. How would you describe your graph here? Well, you describe this graph. Again, if we were using graph paper, this would be a perfectly straight line, but since we're not, it's not going to be perfectly straight. We could describe this graph as a line. But why is this graph a line? Graphs that form a line have proportional relationships, or all their fractions are equivalent, because they lie on the same plane. Okay. Pause the video and soak in all this information. Today we made tables, and then we compared them on graphs of a coordinate plane. Thanks for tuning in.